Hi folks, we're going to take a look at the solution to number 15 on page 49. So this is similar to a question that we solved involving a plane flying with the wind and against the wind. So let's take a look at the question. It says a boat took 5 hours to travel 60 kilometers up a river. So that means against the current. So the current is slowing you down. The return trip took 3 hours. So that assumes that when you're going in the other direction, the current is going to be with you. So it's going to be increasing your speed. And they want to find the average speed of the boat in still water. So just how fast the boat can travel itself, and then the speed of the current. Okay. All right, let's take a look at this question here. And of course, step number 1 is to define our variables. Okay, so I'll say let B be the speed of the boat, and we'll let C be the speed of the current. Okay, so the first part says that you're traveling against the current and it takes you 5 hours to travel the 60 kilometers. So if you're traveling against the current, whatever your speed is, the current is going to reduce your speed. So the speed of the boat minus the speed of the current is going to be the total speed that the boat travels at. And they don't give that to us directly, but it tells us that it takes 5 hours to travel 60 kilometers. So speed is given by distance, 60 divided by time is 5. So here we have 60 divided by 5 is 12. Okay, so that's going to be our first equation. Now, on the return trip, we're going to be with the current, meaning that we're going to take the speed of the boat and add the speed of the current, and that's going to give us what we call the resultant speed, or the final speed. And in this case here, it's the same 60 kilometers, okay, but this time it takes us 3 hours, so equals 20. And there's our second equation. All right, now we have a fairly easy equation to solve, or system of equations. You can certainly use substitution, but I think it's really easy to use elimination because I can easily get rid of the b's by subtracting or get rid of the c's by adding. Now I'm going to add because generally adding causes less issues than subtracting. Okay, so here we have b plus b is 2b. Negative c plus c is 0, which is what we wanted, equals 12 plus 20 is 32. And now we can easily calculate b, divide both sides by 2, and we get 16. And then I'll stick that into equation 2. So b is equal to 16 plus the speed of the current is equal to 20. So c is equal to 20 minus 16, which is just 4. Okay, so we have the speed of the boat is 16 kilometers per hour, and the speed of the current is 4 kilometers per hour. Okay, and let's just take a quick recap of what we did. So first of all, to realize that if you're traveling with the current, it adds to your total speed, and if you're traveling against the current, it's going to subtract from the total speed. And we also use the fact that speed can be calculated by taking the total distance traveled by the time. And then from there, it was a fairly easy elimination. Okay, that's it for this one.